Hello dear students, so welcome back again to my channel Physics with Asiso. Today we'll try to do one more problem related to the rotational mechanics beta. The problem says something like this. A man pushes a cylinder of mass capital M. So this one is your cylinder beta. This one is your cylinder. Only one wave is being seen here right now. So this is a cylinder of mass of your how much? Capital M. Okay. With the help of a plank of mass of your how much? The plank is having a mass of your how much for your M. So this is your plank which is having a mass of your M part of relation on this one. Okay, fine. So a man pushes a cylinder of mass capital M with the help of a plank of mass small m as shown in figure, and there is no slipping at any contact. I already told you in previous section what do you mean by slipping, pure slipping, without slipping, in sliding conditions. The horizontal component of the force applied by the man is given as F naught. See the figure. On the plank we are applying a force of F naught. Then acceleration of the plank and the cylinder will be equal to how much? Now see here the concept of frictional force as well as the concept of rolling is being used better. You know that for no slipping, we have to use the concept that there will be not any relative motion, isn't it? So we'll be using the formula V is equals to R omega for no slipping. So the hence as it is also in the rotational motion, so torque is also acting here. So we need to take the help of angular accelerations, moment of inertia, net torque acting on the given body. So what we'll do is first one is we will try to write all the forces in all the cases of making an FBD. So what is we'll try to do is first we'll try to make an FBD and try to write all the forces part. Now you just imagine that when you're applying the force F naught on the plank, the cylinder is moving in which direction, beta? Opposite direction. That means if this is the center of this one, obviously this is rotating with an angular acceleration of your alpha in the opposite direction. So I'm making an FBD right now for this one. You see, this is your spherical body. Bit down, and this one is your plank above one. Okay, now I'm making an FBD for this one, and I'm applying a force on this one is equal to how much for me? F naught. So obviously this will be having an acceleration of your A1, and because of this one, this starts rotating in the backward direction with angular acceleration alpha, and also in the front direction it is moving. So acceleration of that one will be your A2. Mass of this one is M, mass of this one is your capital M part of relation. Now, if I'm taking the point of contact beta, at this point of contact, as you are applying the force on this one, frictional force on this one is in the backward direction, that is F1. And at this point, the frictional force is your F1 in the opposite direction. Is it clear? Okay. So on this body, as it is rotating, mass is capital M, and at the point of your contact with your ground part, the friction on this ground will be in the front direction. That will be equal to your F2. Okay. So F1 is a friction between the plank and the ground. F2 is a friction between the cylinder and as well as of your ground, isn't it? F1 is a friction between the plank and cylinder, isn't it? F2 is a friction between the cylinder and as well as of your ground. A1 is the acceleration of the plank and A2 is the acceleration of center of mass of the cylinder. Make sure of that one. Now see, as there is no slipping anywhere, you know that at highest point of contact, A1 will be equal to 2 times of your A2. That I already told you in the basic concepts. You can refer my previous lectures if you need to go through how I got that two part of relation. So as there is no slipping, anywhere, I can say that A1 is equals to 2 times of your A2. Why? I'll show you. See, in the last section I told you in this one, when the body is being rotating in the given conditions like this, at the highest point of contact, like the point C, at point C, how much we got? VC is equals to 2. If I differentiate this one one more time with time, one more differentiation with respect to time. So this will give me the acceleration. Acceleration will be given me at a highest proportion for the pure rolling will be equal to how much for me beta? 2V. Okay, sure. So that you can just refer in my previous lectures and previous videos also, you can just go through for that one. So A1 is equal to how much I'm getting? 2 times of your A2. That means I can write from this one, A1 will be equal to your forces applied is capital F minus of your F1 divided by mass of this one, that is nothing but equal to your M. I hope everyone got an idea how do I write in this one. See, on this plank, F naught in the front direction, F1 in the backward direction, Newton's second law, isn't it? So that is nothing but of your F naught minus of your F1 is equals to mass into your acceleration A1. So from this one, I got this given condition. Clear for everyone? The same way A2. Now see A2 if I'm taking right now, what are they acting in this one? F1 is acting in the front direction, F2 is also acting in the front direction. So both of them are acting in the front direction only. So I can write here F1 plus of your F2 will be equal to mass of that body capital M into your acceleration is nothing but your A2. That means A2 will be equal to your F1 plus of your F2 divided by your capital M. So this is the value of your A1 and A2. So this is my equation number 1. This is my equation number 2. Clear? Now see. You know that for angular acceleration formula, isn't it? Net torque acting on that one will be equal to how much better? Tau. Tau net for rotational equilibrium will be equal to your I into your alpha, isn't it? That means alpha will be equal to your tau net divided by your I. So tau net is equal to how many forces are acting by the CR? On the cylinder, F1 and F2 are acting in the opposite direction. This force into perpendicular distance. Again, this force into perpendicular distance. So F1 and F2 are in the same direction right now. Because of F1, it is in the clockwise torque. And because F2, the torque is in the anti-clockwise. So I can write here right now, F1 into your R. So this one is your F1 into your R minus F2 into your R divided by your I. That means here I can write F1 minus of F2 into your capital R divided by your I. Moment of inertia of this body you already know. What type of a body it is? Cylinder. For cylinder it is mr square by 2. That means alpha will be equal to your F1 minus F2 into your R divided by I is equals to your m into R square divided by 2. Now this R, this square will get cancelled. So this will be equal to 2 times of your F1 minus of your F2 divided by your M into your capital R. So this is the value of your alpha, isn't it? So alpha, how much I'm getting beta? Alpha is equals to 2 times of your F1 minus F2 divided by your M into your capital R. Okay. Now. So how many equations we got beta? Equation 1, this one is your equation number 1 and this one is your equation number 2, this one is your equation number 3. So this one is your equation number 4. Alpha value how much we got right now? Alpha is equals to, this is equation number 2, I'll take this one as equation number 3. Now equation number 4 will be equal to A2 is how much beta? A2 will be equal to your R times of your alpha. Isn't it? That means that will be equal to your R into alpha value is equal to how much? 2. So it is 2 into your F1 minus F2 divided by your capital M into your R. This R will get cancelled. So A2 will be equal to 2 into F1 minus F2 divided by capital M. So this is the value of your A2. Once I know the A2, I can even calculate the value of A1. Isn't it? So A1 will be equal to how much beta? A1 is equal to F0 minus of this one. That means if I solve the equation number 1, so from this one I can take the help of this equation. A1 is equals to 2 times of your A2 and equation number this one. So I can get the value of your A1. So how much is you are getting A1? As A1 is equals to 2 times of your A2. Okay, that means this will become for me how much beta? A1 will be equal to your A1 is equals to your 2 times A2 is nothing but 2 into your F1 minus F2 divided by capital A. That means A1 will be equal to 4 into your F1 minus of F2 divided by your capital M. So this is the value of your A1 in terms of your friction, sorry, in terms of your frictions part. Now, but frictions are not given for me. So I can write that one in terms of what beta? In terms of your applied force. Okay, so I can use this relation A1 in any of these equations beta. Alpha is equals to this much, A2 is equals to your F1 plus F2 divided by your capital M. Where is your F0? So yeah, A1 is equals to F0 minus F1 divided by your M. And A2 is equals to your F1 plus F2 divided by your capital M. Isn't it? So individually you can calculate the accelerations from these given conditions. So I can calculate the values and simplify this one. So solve these equations beta. Equation 1, 2, 3, and this one is your equation number 4, and this is your equation number 5. Okay. So solving all these equations, I hope you can solve it. Now everything I have written in detail. So solving all the above equations as per requirement, we will get A1 will be equal to 8 times of your F naught divided by your 3 times of capital M plus 8 times of your small m. So this is the value of your A1. The same way A2. A2 will be equal to your 4 times of your F naught divided by 3 times of capital M plus 8 times of your small m. This is the value of your A2. Similarly, I can even get the value of F1. F1 will be equal to 3 into capital M into F naught divided by 3 into capital M plus 8 into your small m. So I'm leaving this solving of equation for you. We can just try to do it out. And if you can do in detail, you can just give the answer in the comment box to this one. The same way EF2. EF2 will be equal to your M into your F naught divided by 3 into capital M plus 8 into your small m. So like multiple answering में अगर दिया जाए ना तो we'll be getting 4 answers depending upon how he is asking the question part affiliation. So I hope everyone has got an idea. So he is just asking the acceleration तो अपना आंसर इतना ही होना चाहिए. This is A1 and this one is your A2 part affiliation. Clear है सभी को? So एक बार अच्छी तरह से देख लो, बहुत सीधा सीधा application है, simple application. So just practice this type of your questions related to this one. Is it clear बेटा? ओके जनरली जेई मेंस एंड एडवांस का बहुत ज्यादा फेवरेट क्वेश्चन होता है बेटा ये ऐसा वाला कंडीशन में समटाइम्स इंस्टेड ऑफ योर सॉलिड सिलेंडर विल बी गिविंग यू स्फीयर स्फीयर के लिए सॉलिड स्फीयर के लिए मोमेंट ऑफ इनर्शिया कितना हो जाएगा बेटा 2/5 इजंट इट सो जस्ट मेक श्योर दैट वन इफ द बॉडी इज अप्लाइड सम फोर्सेस उस पे थोड़े बहुत क्वेश्चंस आप लोग करने की कोशिश कर लो आपकी जो भी कॉलेज में पढ़ रहे हो आपके पास मेटल में होगा सो जस्ट ट्राई टू टेक सम गुड मॉडल्स एंड ट्राई टू डू ओके सो इतना ही था आज के लिए सो टेक केयर and please try to revise and कुछ doubts वगैरह है तो please let me know in the comment box. I'll try to help it out from my side. Okay, take care beta, bye.